This presentation is devoted to energy demand and supply with focus on the topic of Zernez. Let's assume we have a certain surface where we develop a new region. We start the analysis by placing single-family houses in a couple areas of this district. We're building a road across the area and allow for a couple of bus stops. We assume a number of apartment buildings. In this area, we also plan for public buildings like schools and sporting areas. For recreational purposes, we cater for green space. We allow for offices and shops. All of those buildings and areas require energy services like heating, cooling, electricity, and transportation. The question is, which energy system should we choose? A district heating, a geothermal heat pump, solar, PV, biomass boilers? Which network should we be developing? For electricity, for gas, for district heating, for district cooling? Whatever we choose, we need to limit the cost and the CO2 impact to have a maximum effect. Now we place our district into a bigger picture. When we look at energy resources, we start with renewable energies like solar. It also includes geothermal energy from the ground, either for the heat pump or for direct heating. Wood as biomass is an excellent resource if being reforested. Excess heat from industry processes could provide an excellent resource for energy supply of our district. The most known network is for electricity. Well known and understood is a network for the distribution of gas. What we are adding particularly is district heating and district cooling. Conceptually, that can be put into one energy hub, whereby wood chips, district heat, and natural gas can all serve as a source for thermal energy to either be storage or being used in heat pumps for heating and cooling. In addition, there's electricity which can also be generated from natural gas and stored and provided to the buildings. Such energy hubs are then supplied to very specific kind of heat sources and sinks, like industry, like commercial buildings, like residential building, or a mixture thereof. However, in order to benefit from one another, it's going to be critical to have what we would call a multi-energy grid connecting all those various energy hubs. Such concept is being implemented since 2011 by a real estate company called Zug Estates. They have set themselves a goal for its entire property portfolio to only operate with renewable energy and without CO2 emissions. One such property is Zürstoffi in central Switzerland. The approximately 100,000 square meter area is to be completely CO2 free and is operated largely without any external energy supply. Underground heat storage, PV systems for the production of solar power and solar thermal heat, and the use of waste heat from buildings all provide the buildings with electricity, heating and cooling. The energy network connects all buildings with a geothermal probe field underground heat storage. Building-specific heat pumps provide space heating, hot water and cooling, while excess heat is stored in the summer and harnessed during the winter. In the future, the system of Zürstoffi, currently consisting of heat pumps, tanks, seasonal thermal storage, and photovoltaic and heating systems, could be complemented with natural gas, being entered into reformers supported by electrolyzers to produce hydrogen, either initially for storage or directly running fuel cells, providing further electricity and heating to make the entire area of Surstoffy completely independent of other heat sources, particularly when it comes to electricity. Solar energy can also be very effectively be captured for what we call thermal collection. Thermal collectors require per kilowatt hours only about a third of the space than PV. However, for heating in the winter, as can be seen on this chart, typically the amount of energies provided is not sufficient. So what is sometimes being used with thermal energy collectors, the requirement for hot water is being satisfied, which in the case of Zernez is not part of our simulation.